That's actually very good. I mean, that's sorry. Edwin Savannah. Edwin. Excuse me. Hello, can you hear me? Can you hear me? Hello, can you hear me?
Yeah.
How are you doing today? Gabby Johnson. So give me a few minutes. Let me take down the attendance names. Johnson, Gabby. Got her name here. Lee. Got Lee. Okay. Lee. Oh, yeah. That's it. Ashley Johnson. Gary. Flanagan. Gary. Oh, yeah. Gary. Marcus Johnson. Cross Gary. Fine, marvelous. Okay. Stelling. All right, let's start. So if you have a question, always ask me a question in the classroom, okay? So as we proceed, so let's have this continue from where we stopped yesterday. I'm going to close some pages. I opened too many pages here. I'll close this. Okay. So this is where we stopped. Yesterday, Wednesday, we did all this. So today we'll continue with more concepts. The concept we'll be looking at today include mutual exclusiveness, dependent events, independent events. Let's start with mutual exclusiveness. Two events are said to be mutually exclusive if the two events can never occur at the same time. We say that two events are mutually exclusive if they can never occur at the same time. So, for example, if you are a Democrat, then you are a Democrat. And if you are a Republican, you are a Republican. So you cannot be both. You cannot be a Democrat and a Republican. So another example, even getting a 4 and a 6 when a single card is drawn, that is mutually exclusive. If you look at a card, you can have a card somewhere here. You can have it somewhere right here. Yep, right here. See, 4 is separate. 6 is separate. You cannot get the number 4 and 6 at the same time in a card. So they are mutually exclusive. So with two events cannot occur at the same time, we say that they are mutually exclusive. Before we continue, I would like to remind you that on Monday, we will be coming to the classroom. I think I'm feeling stronger now. Just that I need a little more time. So this weekend we'll take care of that. So on Monday, we'll be in the classroom as usual. Thank you for your patience. So now, next one is at an intersection, for example, turning left or turning right. You can't turn left and right at the same time. Either you turn left or you turn right. So they are mutually exclusive. And then again, you cannot be a king or queen, a king and queen at the same time. Either you are a king or you are a queen. Now, let's come to dependent events. Two events are dependent if and only if the effect of that one event affect the outcomes of the second event in such a way that there's a change. So if I have two events, A and B, you can say that they are dependent if and only if the outcome of event A affects the outcome of event B in such a way that the probability of their joint occurrence changes. Example, the events having a good grades and the event getting a scholarship. The event having good grades and getting a scholarship. So in that event, you have good grades, then you get a scholarship. So there are two dependent events. Having good grades an event, getting a scholarship is second event. So you have good grades, you can get a scholarship. How about this? Parking in a no parking zone, one event. Getting a parking ticket, another event. So two different events. One depends on the other one. If you park in a no parking zone, you get a parking ticket. Now, other one is drawing a card from a deck, not replacing it and drawing a second card. Excuse me. A deck has 52 cards. When you remove one card, what is left is 51 card. So let's say that taking that card is one event. And if you want to calculate the probability of that card, of that type of card, it will be less than 52. So it will change the probability. So selecting without replacement is also a dependent event. Now let's look at independent events. Two events, A and B, are said to be independent if the occurrence of one event does not in any way affect the occurrence of the other event. Okay? If the occurrence of one event does not in any way affect the occurrence of the second event. For example, drawing a card from a deck and getting a queen, then replacing it. So when you draw the card, get a queen, the card was 52, get a queen, then you replace it. So you still have a 52 cards. So when you want to calculate the probability of getting a queen, it will still give you the same probability. Okay? So it's a independent event. Another one is this: winning a Maryland lottery and winning New York lottery. They are totally independent. That you win a lottery in Maryland does not mean that you will win a lottery in New York. So now I'm giving you the background for mutual exclusiveness, dependent events, and independent events. Let's look at the formula we use for calculating the probability of those events. For mutually exclusive events, in general, there's what we call addition rule. Okay, addition rule. Under the addition rule, we have this: the probability of event A or B. So whenever you see the keyword or, that's how you know that you're going to use addition rule. That means probability of event A plus the probability of event B minus the probability of event A and B. Now, this is the general. But when they are mutually exclusive events, that means they cannot occur at the same time. This part turns to 0. In that case, you use this one. But in general, just use this one here. As you work on those events, if they are mutually exclusive, this one will automatically turn to 0. Excuse me. Then for independent events, we have what we call multiplication rule, which says that the probability of event A and B equals to the probability of event A times the probability of event B. So see the difference. Addition rule uses or. Multiplication rule uses and. So that the two keywords. And if there are three events, it means PA and B and C. That means PA times PB times PC. Now, when there are dependent events, we modify the multiplication rule a little bit. Probability of event A and B equals to the probability of A times the probability of B given that A have occurred. So, which means that the probability that event A and B will occur equals to the probability that event A will occur times the probability that event B will occur given that event A have already occurred. So this slash here, this forward slash here means given that. It means given that. So if there are three of them, you just go the same way. The probability that event A and B and C will occur becomes the probability that event A will occur times the probability that event B will occur, given that event A have already occurred, times the probability that event C will occur, given that event A and B has already occurred. Now, this might sound like, gibberish, but when we start working with them, they will start making sense. Let's try this example here. It says, at a political rally, there are 20 Republicans, 13 Democrats, and 16 independents. If a person is selected at random, find the probability that he or she is either a Democrat or an independent. See, the keyword or, which tells us that we're going to use the addition rule here. So first of all, let us get our sample space. There are how many Republicans? 20 Republicans. So R is for Republican, that is 20. 13 Democrats. So D for Democrat, which is 13. And then I is independent, 6 of them. So our total will now become, we have write this time. We got 20 plus 13 plus 6. So we got the sum of this. 20 plus 13 plus 6. 39. So our sample space is 39. 39 is the sample space. It's 39. Our total is 39. So we're looking at the probability of getting a Democrat or an independent. So probability of D or I now becomes probability of Democrats plus probability of independents minus probability of Democrats and independents. See? And for Democrats, we have 13 out of 39, right? So you got, let me go and put it there, where it will look good. So you have, where it will look good, take it to this workbook. So you have that the probability of Democrats, that will take us time, but we can use it. Of Democrats Make it big. So everyone can see it. Okay. Democrats or independents now becomes equals to what we have here. I'll move on this. I can see my equations. Good. We got okay. For Democrats, we have from our listing that Democrats is 13 out of 39. So it's going to be 13 out of 39. 13 out of 39. Yeah, plus independent. And from our listing, independence is 6. Okay. So you have 6 out of 39. 6 out of 39 minus the other one says the formula says minus the Democrat and independent. You cannot be Democrat and independent at the same time. So that would be 0 because you can't be Democrat and independent. Okay. So Democrat and independent is 0 over 39. 0 over 39. And that will give us, of course, in the calculator, we have it. Okay, 13 divided by 39, okay, plus 6 by 39 minus 0 by 39. Give us 0.487. 0.487. Okay. 0.487. Or if you like, you can call it 48.7%. All right. Take it to our main workbook and put it right there for us. Okay. So you can see probability of Democrats plus P of independent minus probability of P minus the probability of Democrat and independent, which is not possible. That's why this side is changed to 0. Okay. So that's one of the examples for using addition rules. Any question on that one? Any question?
Can you explain the 0 over 39 again?
Yeah, because see, if you look at the formula, this is Democrats, which is 13 out of 39, plus independent, which is 6 out of 39. But here, see, minus Democrat and independent. So nobody can be Democrat and independent at the same time. That's why it's 0. Okay?
Okay, thank you.
You're welcome. Any other question? All right, let's look at the next question. It says here, and a card is drawn from a deck and then replaced. Then the second card is drawn. Find the probability of getting a queen and an ace. See, here, in the previous example, we have or, which tells us that we're going to use the addition rule. But here it says a queen and, which automatically tells us that we're going to use the multiplication rule. And what does the multiplication rule say? We have 2 multiplication rules. One for the independent event. Probability of A and B equals to the probability of A times the probability of B. And this one too. So now, in this case, you say we have a card is drawn from a deck. and then it is replaced. So we still have the same number of cards. So he said, find the probability of getting a queen and then an ace. To find the probability of getting a queen and an ace. And so you're going to use multiplication rule. So here we use a Q for queen and A for ace. The probability of getting a queen and an ace becomes probability of a queen times probability of an ace. Okay? Be careful. Let me check this. Okay. That's it. An ace. So we have a queen. And if we look at the card, how many queens we have here? 4 queens. So 1, 2, 3, 4 queens. The probability of getting a queen becomes 4 out of 52 cards. Now, before you make the selection, there is 4 queens, right? So the chance of getting a queen is 4 out of 52 cards. Times. Now, it says here that it was replaced. So you still have 4 queens. So before you make the second selection, you still have 4 queens. And the probability of getting queen again is 4 out of 52 cards. So usually you can make this 4 over 52 times 4 over 52, or we can just do 4 over 52 raised to the power square, 2. So let's do 4 over 52. 4 divided by 52 times 4 divided by 52. 0.006. 0.006. So answer is 0.006 of getting a queen and a queen. 0.006. Any question on that? Any question? Okay, good. Now look at this example here. It says a person has a collection of 30 CDs, of which 5 are country music. If 2 CDs are selected at random, find the probability that both are country music. Now, it didn't tell us whether it is replaced or not. So we assume that it is not replaced. So you can select 2 CDs at the time. For in a fair game, you cannot pick 2 CDs at the same time. You select the first CD before you select the second CD. Now, in this case, he selected the first CD. They didn't tell us that he or she put it down. So that means he didn't put it back. So in that case, it says if the 2 CDs are selected at random, find the probability that both are country music. So what you're going to do here is to use the letter C to represent country music. So we're looking for the probability that the first CD, C1, is a country music, and the second CD, C2, is also a country music. Since we are not told that she replaced it after the first selection, that means it was not replaced. So they will give us the probability of C1, okay, times the probability of C2 is country music, given that C1 is already a country music. See, that's how we solve this. That will give us the answer we are looking for. So C1, that's the first CD, is a country music. And the probability that the second CD is also a country music, given that this first CD has already a country music. So how many country music he has? 30. There are 30 CDs and 5 are country music. So before your first selection, you have 5 country music. So you're gonna be 5 but 30. Okay. Times. Now he did not replace it. So before the second selection, there are now only 4 country music left out of that 29 CDs. So that'll be 4 for 29. And that'll give us the answer we're looking for. I'll write this down. 5/30 times 4/29. I'm gonna take it to where we can do it. We got 5/30, 5 divided by 30, yeah, times 4/9, what 29. Got 0.023 rounded, 0.023. The answer becomes 0.023, 0.023. See? So that the probability that both are country music is 0.023. Any question on that? Any question? Yeah. Any question on that? Good. If there's no question, we can proceed with the rest. Here it says, so well. It says yes. Harris, excuse me. Harris poll found that 46% of Americans say they suffer great stress at least once a week. If 3 people are selected at random, find the probability that all 3 say they suffer great stress at least once a week. At least all of them. In this case, we can say all of it. If 3 people are selected, say we're going to use S to represent great stress. Okay. And it says that 46% of 46% of Americans say that they suffer great stress. I mean 46%, which we change it to decimal. I mean 46 by 100. That will change it to decimal. 1 week. This 1 week. Okay, 1 week. 46. Okay. When you change 46 to decimal, you're gonna have 0.46. You can double check this with your calculator. 0.46. Okay. Now, it says here, if 3 people were selected at random, find the probability that all 3 say that they suffer great stress all at once, at least once a week, so that the probability of that the first person suffered great stress and the second person, S2, suffered great stress and the third person, S3, suffered great stress is probability of S1 times the probability of S2 times probability of S3. Okay. Yeah, then S1, S2, S3. S3, S2, S3. See? That means, and the probability of S, I'll call this PS of great stress. The probability of great stress is 46%. So and they say 3 of them, so it's gonna be equals 0.46 times 0.46. So that 3 of them times 0.46. That will give us the answer. So you have 0.46 times 0.46 times 0.46 0.097 rounded. 0.097 0.097 answer. Any question? Hello guys, any question? Good. Now we're ready to try this one here. Look at this. It says the result of 985 pedestrian deaths that were caused by accidents are presented below. If one pedestrian death is selected, find the probability that the pedestrian was intoxicated or driver was intoxicated. If 2 pedestrian deaths were randomly selected, replacement, what is the probability that in both cases, both the driver and the pedestrian was not intoxicated? So you can see, let's just go through it. See, 985 pedestrian deaths caused by accidents. So when you are given a table like this, the first thing is to find their totals, and I did. See the total for the row, 59 plus 79 give us 138. 266 plus 581 give us 847. And if I add this, you get the total of 987. And the same thing here, 59 plus 266 give us 325. Once you have done the additions, get your totals, you're ready to work. So use P for pedestrian. Let me move this down so we can have enough room. We use P for pedestrian. It is intoxicated. P complement. The driver was intoxicated. Then we have D for driver. Driver was intoxicated, and the D complement for driver was not intoxicated. So in that case, we'll have this. The first part says, if one pedestrian death is randomly selected, find the probability that the pedestrian was intoxicated or the driver was not. See the or, which is the keyword right there, or, telling you that you're going to use additional. See here, the probability that pedestrian was intoxicated or driver was intoxicated is probability of P plus probability of D minus probability of P and D. For the means give us equals, for the probability of P, you have this. Pedestrian was intoxicated. You see the pedestrian right here. Yes and no. 325 out of 985. 325 over 985. Plus driver was intoxicated. See driver right here. Yes, see? the total is 138 over the grand total of 985. See the grand total right there, 985. 985 minus the probability of P and D intoxicated. So this means both the pedestrian and the driver were intoxicated. We are not intoxicated. What? We are intoxicated. See yes here for pedestrian. See yes for drivers. You can see that they intersect here. See, go this way, go that way. See that they intersected here, which is 59. This is showed us that both yes and yes for pedestrian and driver, which means that they say that this number tells us the number of driver, both the driver and pedestrian who were intoxicated, which is 59 minus 59 over 985. So that gives us the answer we are looking for. So let me write this down. We can figure this out in the calculator. 325 over 985 plus 138 over 985 minus 59 over 985. So let's go and put it in a calculator. So you have 325 divided by 985. Okay. Plus 138 and 985. Minus 59. Okay. 0.410. 0.410. Right? Yeah, 0.410 rounded. 0.410. 0.410. I can call it, say, 41% for the pedestrian. The probability that either the pedestrian or the driver was intoxicated is 41%. Any question on that? Yeah. Excellent. So you're getting it. You're having fun. That's good. Next one is was if two pedestrian deaths are randomly selected with replacement, what is the probability that in both cases, both the driver and see the one we just did is or. Now I did and both the driver and the pedestrian was not intoxicated, which means we'll be looking at the no side. No for pedestrian and no for driver. So we're looking for the probability that both the pedestrian and, so that means that we are doing multiplication rule. So both the driver and the pedestrian are not intoxicated. So look at no for drivers right here. Okay. Look at no for, so look at no for driver is right here. This from here. No for pedestrian is right here. So this number here presents the number of pedestrians and drivers who are not intoxicated. That is 581. So the probability of getting, there are two of them selected. Remember, two pedestrian deaths selected. So the probability that in both cases, both the driver and the pedestrian are not. See, that means D complement, and the P complement means not intoxicated. Okay, will be the probability of D complement times the probability of P complement. So have it here as both of them 5, 6, no for pedestrian and no for drivers, which intersect here. 581. So you have 581 over the grand total of 985 here. 985 times 581. Okay, over 985. So 581 over 985 times 581 985. That gives us the answer widely. So 581 over 985. Okay, times, because there are two of them, 581 over 985. 0.348 rounded. 0.348 rounded. I can call it 34.8%. Any question on this? Any question?
No.
Well, this is our last example for today, and I will see you on Monday in the classroom. Hopefully by then I will finish with some of the, most of the gradings. Yeah? You guys have a nice weekend. If you have a question, you can ask me. Any question?
Professor,
Yes, sir.
yeah,
What's
did
the
you
name?
give me for attendance?
What's
Kyrie.
the name? What's the name?
Kyrie.
Kyrie. Say Kyrie.
Yeah.
How you spell your last name?
Kyrie. Puryear.
Okay, I see it. Kyrie, Kyrie, right? First name is
Yes.
Kyrie. The last name Puryer. Okay, I see it. What can I do for you, Mr. Kyrie?
I was trying to see if you had me for attendance.
Oh yeah, I got your name here. Hold on. Yeah, I got
And
you.
the other day you worked. Did you give me for attendance the other day too? Or
Huh?
I said for the other class when we was on virtual, did you give me for the attendance too or no?
You have to tell me the date. Are you talking about Wednesday?
Oh yes, Wednesday.
I didn't. Were you here on Wednesday?
Yes, sir.
Okay. No. What I'm gonna do? I'm gonna review the video for Wednesday. Then if I see your name, then I'll update it. Okay.
Okay.
Hmm.
You have a good day now.
You too. All right, guys. I see you on Monday. Don't forget to do your test. One this weekend.
Okay, and a nod for attendance as well.
What's your name, sir?
A nod Bowens.
Yeah, I checked your name.
Okay, just making sure.
Yeah, I checked it. Yeah. All right, guys. Have a nice weekend.
You too.